we can make the state explicit by extending the language. And if we do that, then we can directly observe the sequence of values from within the program. And this was not possible in the functional paradigm, so we've extended the paradigm with a new ability. We call the extension a cell. We pick the word cell to avoid confusion with related terms such as the overused word variable. So a cell is a box with a content. The content can be changed, replaced by another content, but the box remains the same. So the same cell can have different contents. We can observe then the change by looking inside the cell, and the sequence of contents is a state. So if we have here an unbound variable, C, we bind it to a cell, so C is bound to the name of the cell, the box, and inside this box we put a variable A, for example, bound to 5, and we can replace this variable by another variable, giving the cell a new content, B, for example, which might be bound to 6. So a cell then is a box with an identity and a content. And the identity is a constant. It's called the name or address of the cell, and the content is a variable in the single assignment store. And this content can be replaced by another variable. So in this example, if we have A and B equal to 5 and 6, we create a cell C, which is bound to the variable A, which is referred to by identifier A and has content 5 here. If we display this using the read operation here, the access operation or read operation of the cell, we will display 5. Now we can change the content. In fact, we replace the content of the cell by to variable B, so it no longer references variable A, but it references variable B. If we display it, then it will display 6. So we will add cells and their operations to the kernel language. This gives us a new kernel language of the new imperative paradigm. So cells have 3 operations. So there's the creation of a cell, there is the assignment or changing of the cell's content, and then there is the read or accessing of a cell's content. So we create a cell with initial content A, and C is bound to the name of the box, the cell's identity. We can also do assignment, replace the cell's content by a new content B, and finally we can access the existing content. We bind Z to the existing content of the cell. And both of these we will first check that C is in fact bound to a cell's identity, because if it's not, we have a type error. So here's some examples. So we create a cell, so variable x here, little x, is bound to a cell with initial content 0. Now we replace the content by 5, so this content is 5. And if we now say y is equal to x, we have another variable y which refers to the same cell. Assume now that we change the content of y to 10. Since y refers to the same cell as x, in fact we have changed this cell, this content to 10, and so x also has content 10. In fact, x and y refer to the same cell. They are bound to the same name, the same address, so if we compare them, we get true. So here's another example. So we have now 2 cells. We have one cell bound to variable x, another cell bound to variable y. Both of them have content 0. If we now compare x and y, this returns false. This is because x and y refer to different cells. We are here comparing the identities of the cells. If we compare the contents of the 2 cells here, content of x compared to content of y, this will return true because the content is 0 in both cases. It has the same content.